All right, we're going to look now at the second page of section 9-6, and now we're going to start getting into ones where they're not both lines. In general, one's going to be a parabola, one's going to be a line, maybe both are parabolas. In this case, I see that it is x squared, so I know this one's going to be a parabola. This is an mx plus b form, so this is going to be a line. So I'm going to have one line and one parabola. In this, for this particular problem, when I go and solve it with algebraically, they're both equal to y. So if you take a look at that, I can take this 2x minus 1 and put it in for y in my other equation. Okay, so I'm basically setting them equal to each other. So I'd have x squared minus 1 equals 2x minus 1. Now, I have x squareds with x's. We talked a lot about this. This is now kind of like the middle column of our flow chart. And in that middle column of our flow chart, we would have where it has to set, this would be saying there's nothing to FOIL distribute, and then we have to get one side equal to 0. So we'd have subtract 2x and add 1. That makes this side 0, but what I do to one side, I have to do to the other, so I'd have to subtract 2x and add 1. So in this case, I have no other x squared, so it's x squared minus 2x, and then negative 1 plus 1 is also 0. For this problem, I'm going to have to factor this now. Again, the first thing we always look for when we factor is to look for a GCF. In this case, we have a GCF of x. So I'm going to have my x in front with one set of parentheses, and then divide everything by x. So x squared divided by x is x, and negative 2x divided by x is negative 2. I can't factor inside there any further, so I'm going to set each of my factors equal to 0. Remember, factors are separated by multiplication, so I'd have x equals 0, and then x minus 2 equals 0. So one of my x values is already here at 0. The other one I'm going to have to add 2. My other x value would be then 2. All right, but again, just like the last one, I have x's and y's now. I can take my two x values and plug them in for either x. The bottom one's going to be a little bit easier, so that's what I'm going to use. And so I would have y equals 2 times 0 minus 1. So that would give me negative 1. So those two are ordered pairs. So when x is 0, y is negative 1. That's one of my ordered pairs. And then I'm also going to plug 2 in for x. So I do y equals 2 times 2 minus 1. So 2 times 2 is 4, minus 1 is 3. So I'd get 2 comma 3 as my other point. So that means when I graph this, I should actually have 2 intersection points. So I'm going to go back up and graph this now. I'm going to use green for the first one. So we kind of have to remember a little bit from our parabolas. Also, if you wanted to use Desmos or a graphing calculator, you could do that as well. But I'm going to try and do this without that for now. Remember, this is going to be a parabola that's moved 1 unit down. And then we follow our normal parabola pattern. Remember that table for the parent graph for parabolas was negative 2, 4, negative 1, 1, 0, 0, and that was our vertex. 1, 1, and 2, 4. So from this new vertex, I'm going right 1 and up 1. That's the 1, 1. Left 1, up 1. That's the negative 1, 1. And then right 2 from the vertex and up 4. And then left 2 from the vertex and up 4. So there's our parabola. This is still a line, so mx plus b. It's starting at 0, negative 1. And we're going up 2 over 1, up 2 over 1, up 2 over 1, down to left 1, down to left 1. And we see that it is intersecting here and also right here, which is at 0, -1, and 2, 3, which is what we got when we solved it algebraically. All right, pulling out our points from our table. So again, I'll do the green is our parabola, y equals x squared minus 1. The blue is our line, y equals 2x minus 1. All right, so for our parabola, we had -2, 3, 0, -1, 0, 0, -1, 1, 0, and 2, 3. Again, those are just the points I plotted. And then for our line, we had -1. We'll start with -1, -3. 0, -1, 1, 1, 2, 3, and 3, 5. Again, we're looking for where the points are the same. So each of them have 0, -1, and each of them have 2, 3. So therefore, those are our two solutions, which again match all of our other ways as well. Just want to get you set up for the next one as well. I'm not going to finish it all for you, but you can. For the next one, algebraically, again, they're both equal to each other, so I can take this x squared minus 4, which is equal to y, and put it in for y in the other equation. So that's what I'm going to do first. All right, again, now we'd be in that middle column of the flow chart. So there's nothing to fully distribute. We want to get it equal to 0. So I'm going to subtract x and add 2. That's what would make the right side 0. So I want to do it to the left side as well. And so I have no other x squareds on the left, so just 1x squared minus the 1x we just subtracted. -4 plus 2 is -2. All right, in this case, now again, we're going to factor. We look for a GCF. This particular problem does not have a GCF, unlike the last one. And there's a 1 in front of our trinomial. So again, now we're going to SAM factor. So don't forget about that SAM factoring. So we'd be saying what multiplies to x squared, which is x times x. What multiplies, and remember, m stands for multiply, multiplies to -2, a stands for adds to -1. Well, the only thing that multiplies to 2 is 2 and 1. It has to multiply be negative, which means I need opposite signs. And my larger number has to be negative because it has to add to -1. So it's -2, +1. Again, we're going to set each of those factors equal to 0 then. And we get adding 2. I get x equals 2 as one answer. And then subtracting 1, I would get x equals -1 as my other. Again, don't forget, we need to go back and get y values now. So it's easier to probably put in the bottom equation, so that's what I'm going to use. So my first equation, I'm putting 2 in for the bottom equation. So it's, remember that bottom equation was x minus 2, so it's going to be 2 minus 2, which is 0. So the first solution is going to be 2, 0. The second one, I do -1 minus 2, which is -3. So we'd be at -1, -3. All right, so you're going to, for this one and the next one, you are going to graph. If you need to use graphing calculator or Desmos, go ahead and graph using that. Make the tables. And And again, your solutions should match, always match. They should all be equal. If they're not equal for some reason, there's a mistake somewhere.